Okay, so for the final subtopic, okay, so we're gonna take a look, okay, on the function with three independent variables. Okay, so still on the domain and range. Okay, so it's actually for this one, okay, it's similar to what we have discussed at the beginning of our class in the second week. Okay, so the definition of domain and range will be similar. Okay, even though function with three or more than that, okay, is gonna be the same. Okay, so if we can recap back, okay, on whatever that you have learned on domain and range. For example, okay, based on this example 5, okay, so we have, okay, so we have w equal to a square root x square plus y square plus z square. Okay, so in the previous subtopic, okay, function with two independent variables, okay, so we only, the for the domain, okay, it consists of x and y. Okay, but for a function with three independent variables, okay, so now the domain consists of x, y, and z. Okay, so the condition that we must set, okay, in order for us to find the correct domain will be similar as what we practiced previously. Okay, so in this case, for example, the answers for domain for this one would be x, y, and z is belong to real number, okay, with restriction inside like this, is greater than or equal to 0 because we have square root terms over here. Okay, so what about the range? Okay, so the range, okay, the range of now, okay, is for the output values of w. So now, well, w is belong to real numbers. Okay, so do we have any restriction for the range for this one? Okay, so since we have a square root terms over here, so obviously that the values of w, okay, will be equal to or greater than 0. Means that it's gonna be a positive values only since we have square root terms over here. Okay, so you can see that actually for this one, okay, we use the same way on how we find the domain and range for a function with two independent variables. Okay, so let's see on B, for example. For B, okay, still we have a square root terms over here, but then we have like this. Okay, so we have a bracket over here, suppose. Okay, so the domain for this one, okay, so the domain for this one, okay, if we take over here, the term inside is supposed to be 1 minus x squared plus y squared plus z squared, like this, right? Okay, supposed to be greater or equal to 0. Okay, so if you make some modification, so you're gonna have x squared plus y squared plus z squared is less than or, sorry, should be 1 over here because we move this one. Okay, so the domain, okay, so the domain, either you use this condition or you can also write as the domain would be x, y, and z is belong to real numbers, or the condition might be x squared plus y squared plus z squared is less than or equal to 1. Okay, so what about the range? The range would be range of f over here. Okay, so since we have this restriction, right, so from here we know that, okay, the values of w would be a real numbers, okay, with that w is only between 0 up to 1 only because of this restriction, because we need to have a positive values inside, right? Okay, so you can practice how can you solve for C by your own, whether you can solve it or not. Okay, try to recap back on whatever that you have learned previously. Okay, so the next one, okay, so in the previous videos, okay, I introduced on level curve and contour map. Okay, but that one is for a function with two independent variables. But when we move to function with three independent variables, okay, we now are trying to find the level surface. Okay, because when we talk about function with three independent variables, okay, it's no longer in 3D surface. It's supposed to be a 4D space. Okay, so when we talk about 4D space, okay, it's not possible for you to sketch it manually. Okay, 3D is still possible. We can use trace and everything. But when we talk about 4D space, okay, it's no longer as what we get for 3D surface. Okay, so the idea on level surface means that for any values of W, okay, we can have a level surface. Okay, so like this, the graph of the equation will generally be a surface in 3 space, which we call the level surface with constant K. Okay, so if we have a level curve, okay, for example, we have a collection of level curve, we call it as contour map. Okay, but when we move to level surface, okay, normally we will have a collection of level surface, but since sketching of 3D is not as easy what we think, okay, so normally we will limit the level surface at certain values only. Okay, so that's the clue on example 6 over here. Sketch the level surface of F for K equal to 0, 1, 2, and 3. Okay, so means that K is going to be substitute at F over here. Okay, it will be similar as what we practice on level curve actually. Okay, so now if we substitute, okay, so we're going to have x squared plus y squared plus z squared equal to 0. This is going to be the first one. Second one, x squared plus y squared plus z squared equal to 2 is going to be the second one. And the last one, sorry, 1 should be start with 1, x squared plus y squared plus z squared equal to 2. The third one, and x squared plus y squared plus z squared equal to 3 over here. Okay, so by right, if you take a look on this one, okay, so this is the general equation of a sphere. Okay, so the level surface that we are trying to sketch is actually a collection of a sphere. Okay, so if we sketch it in 3D, okay, so here is for the first one, okay, and another one is actually for the second one would be the first sphere. Okay, like this, a first sphere. Okay, the second one, okay, so we have another sphere like this. Okay, and then the last one, you have the biggest sphere over here. Okay, so technically, if level curve, okay, we have a collection of level curve, you got the contour map on XY plane. But when we talk about level surface, you're gonna have a surface, a 3D surface, because you will have because it's not possible for you to sketch for 4D, right? Okay, so that's why we will give you a specific values for you to get the level surface. Okay, and a simple analogy, okay, when we talk about level surface, normally we'll give you the values for for that function, okay, in order for you to get that surface. Okay, so since this one is the simple surface, okay, because this is the general form of a sphere, so that you can just directly get the level surface. But if the given equation is not as simple as what we think, okay, you must start with traces for every level surface. Okay, every level surface, and then you combine it. Okay, so it's a little bit messy for you to sketch it. Okay, but for level surface, normally we will capping for certain values only. Okay, so like what I give to you in the exercise, for example. Okay, they give you the given W is equal to this one. Sketch the level surface of the function for W equal to 0, for example. Okay, so you're gonna sketch it, okay, for a specific values of W equal to 0 only. Okay, so because like I said, to sketch a 3D space is not easy as what we think. Okay, so that's why we limit for a certain values only when we talk about level surface. Okay, but the most important is, okay, you must be able to differentiate what is level curve and what is level surface. Okay, level surface is a 3D space, 3D surface, but level curve is 2D. Okay, is on XY plane only. Okay, so this will be the last subtopic in this chapter that I would like you to try by your own on this exercise. Okay, so that from there you can get an idea what is the difference, okay, between level surface and level curve.